Welcome to the Actionable Continuous Delivery Metrics. I'm Alagu, and I'm part of the sales team here at ThoughtWorks. And today we have Suzie Prince and Aravind. I'll let them introduce themselves.
Hi there, I'm Suzie Prince. I'm Head of Product here at ThoughtWorks Studios, and I'm happy to be one of our presenters for our Actionable Continuous Delivery Metrics webinar today.
Hi, my name is Aravind. I'll be the other presenter in this webinar. I'm the product manager for GoCD, a continuous delivery server that we'll be talking about a little bit today.
So before we go ahead, a little bit of housekeeping things. The chat in the Zoom meeting has been disabled. If you have any questions, you can use the Q&A session right at the bottom. Ask your questions. We do have some time at the end to answer these questions. If we are not able to answer these questions, we'll probably answer them by email. And before we go ahead with the webinar, I'll just tell you all a little bit about ThoughtWorks, of who we are, and then we will move on to the webinar. So ThoughtWorks is a global technology consultancy founded in the year 1993 in Chicago. We work with enterprise clients to solve their most difficult technical challenges. In the year 2000, Martin Fowler joined ThoughtWorks as the chief scientist, and following which, Martin took this concept of continuous integration mainstream. ThoughtWorks took the lead on that in creating a first open source continuous integration server called Cruise Control. In the year 2006, we formed a product division called ThoughtWorks Studios to bring our developer tooling expertise to the market. Out of which, one of the products that we got out was a product called Cruise, which was the first continuous delivery server, which was then renamed to GoCD. The product manager on GoCD was a gentleman named Jez Humble, who wrote the book Continuous Delivery. So you would see similarities of the concepts that are mentioned in the book and in this product, GoCD. We then open sourced GoCD in the year 2014, following which there's a rich community of contributors and plugins from there on. Over to you, Suzie.
Thank you, Alagu. Before we dive into the content of our webinar today, we would like to walk you through the agenda so you know what content we'll be covering and you can follow along. In many of the examples today, we are going to talk about our continuous delivery tool, GoCD. So at the very start, we'll give you a quick introduction to that. Then we'll define continuous delivery. We know many of you are familiar with continuous delivery, but to ensure that we all understand it, we'll just review our definition. Then we're going to start to explain why you should measure your continuous delivery process and why that's valuable, followed by what metrics we suggest that you gather, and then we'll dive into some examples that explain why certain continuous delivery metrics are useful and what they reveal about your continuous delivery process. And finally, as Alagu said, we have time for questions at the end. So please post your questions and stay till the end so we can answer them for you. So here's our agenda. And now over to our introduction about continuous delivery.
Thank you, Suzie. Some of the examples you see will be screenshots from GoCD, a free and open source continuous delivery server that we work on at ThoughtWorks. We also try to show you how these metrics can be visualized manually using a spreadsheet or in other tools. So knowledge of GoCD is not a prerequisite for this webinar. All right, first, an introduction to continuous delivery. Alagu already mentioned Jez Humble was the co-author of the book Continuous Delivery. He uses this definition for the practice. I'm going to read it out. It says, continuous delivery is the ability to get changes of all types, including new features, configuration changes, bug fixes, and experiments into production or into the hands of users safely and quickly in a sustainable way. I think it's important to notice that the definition talks about all changes to a software project, not only the features, but all other changes, including experiments and configuration changes. Right? In practice, a simple CD pipeline or continuous delivery pipeline can look like this. The material on the left is usually a repository, such as Git or SVN. In this webinar, you might hear us refer to this as VSM, or the value stream map. That is GoCD's representation of a CD pipeline. In this example shown here, the delivery team commits a change and GoCD runs build and unit tests. If these tests fail, the team immediately fixes any problems. The new version with these fixes goes further along the pipeline, along the CD pipeline. If tests further down fail again, the team fixes them as quickly as possible. In this example, we also have a part of the CD pipeline called the UAT, the user acceptance test. This is meant to model a manual step. In continuous delivery, the team makes a decision as to when to release. The key is that the software is always in a state where it can be given to customers. In comparison, continuous deployment would not have any manual steps. A build that passed all the automated tests would be deployed to production automatically. This process happens over and over in the lifecycle of an application. In this webinar, we're going to be looking at metrics around this process, which ones to choose and why.
So now we'll move on to why you should measure your continuous delivery process. There are three main reasons why you should gather data about your continuous delivery process. The first reason is that data is an important part of the feedback cycle and is paramount for continuous improvement. Feedback is a significant part of the continuous delivery journey, and your continuous delivery metrics will help you and guide you along that journey. To understand how that works, consider a feedback cycle like plan, do, check, act. Metrics are a way to set specific measurable goals in the plan section. Direct your activities towards achieving those goals during do, and help you understand if you are achieving those goals during check. The metrics really are the feedback in the feedback cycle, and they will help you get better at continuous delivery. So that's the first reason why you should gather them. Secondly, the specific data values that you gather will be very useful for you to predict your future behavior. Gathering data about your continuous delivery process will allow you to predict your future behavior and allow you to provide more accurate estimates, maybe to your business or between your teams. For example, if you know your cycle time, when asked for questions about when things will be ready, when can we deliver that, you will be able to give more accurate answers to those questions. The data may also allow you to estimate the cost or the value of an activity. For example, if you are considering parallelizing some tasks in your process, or perhaps removing a manual approval step, if you have data that can explain the time it takes to do those activities, or the occurrence rate of those activities, or the delay that those activities cost you, you'll be able to calculate how many days you might save by doing those particular activities. And if you have some understanding of the cost of time to your business, you may even be able to put a dollar amount to the activities that you're doing, so the amount saved or the amount generated. So you can see there where data allows you this predictability. And then finally, data about your process will allow you to benchmark yourself and understand where your organization compares to other organizations. Now, at first, this might seem like something that isn't very important to do, and often we do not necessarily advocate for comparisons between teams or comparisons between organizations because it's not generally useful. However, in this case, we believe reports such as the State of DevOps report, and you're seeing some of the data from that there, are useful ways to understand how you compare to the highest performing teams. By understanding your metrics, you'd be able to understand where you fall compared to those teams, and that would help you seek help or perhaps set future goals. So as you can see, we have 3 different reasons for measuring your continuous delivery process. The first is part of a feedback cycle, the second is predictability, and finally, we've just explained benchmarking. Each of these ways provides a lot of value to you and your organization and will help you significantly on improving your continuous delivery and along that journey that you're going on. So how do you go about measuring your process? We've got a quick checklist that will help you get started when you begin to capture your data. First of all, we recommend creating a value stream map, or VSM, that was introduced earlier. This will show you your path to production, and we'll show you some more of those later on in our example section. We're going to show you them in GoCD, but this is also something that you can do with pen and paper or also on a whiteboard. So after you've mapped out your value stream, we recommend you select the metrics that are important to you. We're going to suggest 4 metrics that you consider, that you should consider when you begin this process. And of course, once you've begun capturing your metrics, you need to review them. You need to use them in part of that feedback cycle and move on to learning from your results. So what should you measure as part of your continuous delivery process? There are many different options for things that you could measure and data that you could gather. This is just a short list of things that we have found in continuous delivery case studies, DevOps reports, and our own work with the development and DevOps teams. You can see that there's a variety of different metrics that teams do capture about their process. We see cycle time, escape defects, production outages, deployment frequency, and we certainly do not suggest that you start to gather all of these and you start by measuring every single one of them. There are 4 in here that we consider to be the starting point, as they are generally valuable and add help to all organizations. These are throughput, cycle time, mean time to recover, often abbreviated to MTTR, and failure rate. Let's look at these 4 a little more closely. Let's define them and talk about why we think they're important. So the first of those is throughput, and this is actually calculated often as a percentage. It's really the answer to the question, how often does code reach a certain point in your continuous delivery pipeline? For example, how often do you deploy to production? Or how often do you go to another significant point in your pipeline, such as a staging environment or perhaps UAT? We selected throughput as an important metric to measure, as this is often the metric we hear cited when organizations are striving to improve their continuous delivery process. You may even hear yourself say, we want to be able to deploy multiple times a day, or we can now deploy multiple times a day. Understanding how often you can deploy is important to understanding the efficiency of your continuous delivery pipeline, and it is a key measure of continuous delivery success. So that's our first metric. Let's have a look what that looks like in practice. In this example, we're going to consider production deployment as a significant point in the continuous delivery pipeline. And we're counting the number of times a deployment to production happens versus not happening, as I said, a percentage. In this case, we have 8 instances or opportunities to deploy and 2 deployments. Therefore, we consider this to be a throughput of 25%. Moving on to our next metric, which was cycle time. This is a duration of time. And it's again an answer to a question. How long does it take to go from one point to another point in the continuous delivery pipeline? For example, How long does it take to go from a code commit to that same code running successfully in production? Whereas throughput, the previous metric, was the number of times something happened, cycle time is the cumulative elapsed time that it took for that thing to happen. Now, we've selected cycle time as an important metric to measure, as it is a key element of lean theory. In fact, many people believe that if teams and organizations only concentrated on lowering their cycle time, they would improve and add much value to their organizations. In addition to this aspect, there's also the fact that cycle time is an important metric to help inform business decisions, and it helps a lot with planning. Finally, when we consider the delivery part of cycle time, and we do in our definition, so this is the code commit part to the production part, it's actually a very simple metric to calculate, and it's one that we definitely recommend that you start with. We have a caution about cycle time though. You may see cycle time used interchangeably with a term called lead time, and there can be a lot of confusion between what these two terms mean and whether they're different. Our recommendation is that it is only important for you and your organization to understand your definition. So make sure that you define what you mean when you say cycle time, or if you choose to say lead time, define that as well. Be consistent with your definition, so every time you use cycle time, use the same definition. And avoid simply saying cycle time without qualifying what it means in your context. So make sure you say from a code commit to that same code running into production to be clear about what it means. So here's an example of cycle time. We calculate from the time when a commit, so that's the very start of our pipeline here, until the code goes to production, which is the very end of our pipeline. In this case, although other points in the continuous delivery pipeline happened multiple times, it was only after 3 days that the deployment actually happened and that piece of code went to production. So we would calculate the cycle time in this example as 3 days. 3 days from the code commit to that same code being in production. On to our next metric, which is failure rate. This is actually also a percentage, the same as throughput. And it's the percentage of changes that result in a failure. There are different ways to define failure rate. It could be the percentage of changes that break a build, or it could be the percentage of deployments that result in a service outage. The reason we've suggested that you calculate and measure your failure rate is that it is one measure of stability in the continuous delivery process. We often hear that organizations fear frequent quick changes, so lower cycle times and higher throughput, as these are to increase these and lower your cycle time, it's at the expense of quality. So to manage that, we suggest you measure a failure rate as a measure of the quality in your system and of the outcomes of your continuous delivery process. So it really helps you understand, are we getting a lower cycle time and a higher throughput, but with a higher or lower quality? In this example, we want to measure the failure to deploy, the failure of a deployment. So we count pipeline runs that do not result in a deployment. In this example, we can see that 75% of our pipeline runs do not result in a deployment to production. In this specific example, you will see that the failure rate is actually the opposite of the throughput that we calculated earlier. But it may not be the case with your process, depending on how you define throughput and how you define failure rate. In addition, if you have manual approvals or you're calculating the failure rate of a build failure rather than a deployment failure, you wouldn't have that same inverse of throughput. And this is, again, a good example of why being very specific about your definition in your context is an important part of getting measuring and calculating metrics right. So finally, our last metric is mean time to recover. And this is a mean duration. How long does it take to fix a failure? For example, how long does it take to fix a broken build, or how long does it take to restore service during a deployment failure? Like failure rate that we just talked about, mean time to recover is suggested as another measure of stability and quality in your continuous delivery process. Yet rather than being solely focused on failures or minimizing failures, which frankly could be achieved by just not deploying to production, this is a way of understanding how well we can recover from failures. When the inevitable failures happen, how long does our service take before we can bring it up? And it is a key to understanding the health and stability and the robustness of your continuous delivery process and the changes that you're making. So our last example here, how we calculate mean time to recover. We calculate mean time to recover from a build failure to when the build is fixed. So we're looking for when specific points in our process turned red or they failed to when they next became green and succeeded. And we measure the time between the failure and the following success. As this is a mean time, we look at multiple occurrences of this failed succeed cycle. Here the build failure is immediately fixed in both occurrences of the failure, and so it was easy to calculate as a mean time to recover of 2 days. So there we've suggested the 4 metrics that you can use to get started when measuring your process. And they can be used individually, and they can also be used all together to provide an overall view of your team or organization's ability to deliver value. They can also be applied no matter what you are building or what you are deploying. So this makes them very generally and universally useful. In some cases, you will want to apply them more specifically. So for example, in terms of build failure rather than deployment failure, or you may want to do them more generally, throughput to production rather than throughput between 2 stages. And this will all depend on your needs. Should these 4 not be appropriate metrics for you to gather, that's fine. You could select some different ones, perhaps from the list here. But we just want to talk a little bit about how you should select other metrics if you're not going to select these 4. The first thing is you should be thoughtful about what you're selecting and take that process, really think about what it is that you're trying to achieve with those metrics. And while you're doing that, be wary of vanity metrics. These are metrics that are easy to measure, but provide little value to your organization. A good example of this is actually one that's very common, which is bugs fixed. We see many organizations tracking bugs or defects fixed with little understanding about whether this really improves value to their process or to their customers. You should also be wary of metrics that are unclear. So as I've talked about before, be sure to define what you mean by your metrics and educate everybody what they mean. Make sure that your metrics are visible. We suggest putting these up on big visible dashboards in your workplaces and having regular reports that people will read to ensure that the metrics are really used. Avoid assisting every team uses the same metrics if their goals are different, and avoid comparing across teams and creating valueless competition. Be aware of the Hawthorne effect, sometimes called the observe effect. This is an effect where individuals modify their behavior in response to the awareness of being observed or measured. We actually know of an organization who started to measure test coverage, and in response to And in response to that, people began writing tests without assertions just to increase the test coverage results and get the metrics that they needed. We believe that the Hawthorne effect can happen, and we suggest that you become aware of that and look out for it and be aware of that when selecting metrics. And finally, avoid gathering all the data just because you can. Be specific and clear about what is important and change it when that no longer is useful for you and measure something else. So now we're going to look at our metrics in action.
Right. Thank you, Suzie. Let's take a hypothetical scenario and see how metrics can be used to improve your CD workflow. Next slide, please. This is an example VSM or value stream map that you can see in GoCD. This represents the continuous delivery pipeline. It runs the build and some unit tests, and then runs integration tests, smoke tests in parallel, and then regression tests. Finally, there is a UAT, user acceptance test part, and then the production deployment. Let's say that the complaint from the business is that they don't get value very often from all the work that's happening. Let's see how the 4 metrics we selected can help you understand what's happening. Suzie recommended starting by looking at your throughput, since that was highlighted in the initial, we recommended it because that was highlighted in the initial complaint. So to figure out whether low throughput is a problem, you would look at the run frequency of that part of the CD pipeline you care about. GoCD has a paid analytics plugin, which helps you find a lot of information about CD metrics. Let's take a look at the runs of a specific part of it, say build and unit tests. You're seeing a chart showing every run of this part of the CD pipeline against the duration it took to finish. The green and red dots signify the final state of the run. Focusing on the run frequency, which can be seen there, we can see that it ran over 100 times over the last 30 days. During that same period, the production pipeline, though, ran less than 20 times. This clearly shows that less than 20% of the runs are reaching production and resulting in low throughput to production. If you're tracking these manually or in a spreadsheet or in some other tool, you'll see more failures. You'll be able to see more failures on the way to the production part of the CD pipelines if you plot information like this. In this example, when you track and plot the run times, you'll see that in the same time period of 5 days, build and unit tests ran about 14 times and production ran about 6 times. There's definitely some confirmation that what the business is saying, their complaint, is reasonable. The main signal is that the throughput is low, but there may be many other reasons for it. It could be slow running builds, or it could have to do with builds that fail often. It could even be long-lived feature branches or pull requests, which are not merged often. The development team might be working hard on their branches, but the business won't see that value till the changes are deployed often. Metrics such as cycle time, failure rate, and MTTR, which we will look at soon, will help you understand what may be causing the low throughput and help you resolve that issue. If your problem is that you have work going on in long-lived branches, you can consider feature toggles and trunk-based development. Let's see if we can find out what parts of the CD pipeline are causing a low throughput. In GoCD's analytics plugin, you can choose to see details about the cycle time between any 2 points in GoCD's value stream map. In this example, you can see the value stream map and then choose to see analytics between the build and unit test pipeline and the production pipeline. The GoCD analytics plugin shows you how long it took on average to go between these 2 parts of the value stream, including all parts of the pipeline in between. In this screen, you're seeing each run of the CD pipeline or GoCD's VSM from the build and unit test part to the production part. It's showing a throughput of 20% and an average cycle time of about 1 hour and 33 minutes, including some runs you'd need to scroll down for. You can even click on that more info and drill down into each individual run to see how long each part of the CD pipeline took. Here it is showing you wait times shown in gray and run times towards production. Each stage is shown separately. If you're trying to do this manually or using some other tool, when you track the start and end time of different parts and plot them, you could see something like this. In this example, there are some long-running parts of your pipeline shown as a wide bar, as in regression here, and some long delays due to manual approvals, which are showing in between there. Often, low throughput is caused by a cycle time that is slow. Steps that are slow to complete and require lots of wait time will lead to overall low throughput. Focus on the slowest steps. This is what will give you the most gain. Convert manual approvals into automated ones by increasing your level of confidence in the tests and automation. Rewrite them if possible. Parallelization is another possibility. If you draw or get the value stream map and truly understand the dependencies, you might find opportunities to parallelize. Maybe it is possible to start the slow running tests earlier on in the process, decreasing cycle time. Another aspect of reduced value delivered is a high failure rate. In an earlier image from GoCD, you could see that there were many failures at different parts of the value stream map. They're all highlighted here. Looking at one of those parts, you can see that it has a high failure rate, shown as failure rate on the top right there. And there could be, and if you're tracking these manually or in some other system, you'd look at failure rates of the parts of the pipeline you care about. In this example, you see a 67% failure rate. Please remember that pipeline failures are not inherently bad. They prevented something from failing in production. However, having too many unexpected failures can reduce throughput and reduce delivered value. Common causes we've seen include flaky tests or tests that are hard to run locally. Try and fail fast by running high value and fast running tests or by bringing them to the front of the CD pipeline to get feedback faster. Make sure that tests can be easily run locally before checking in. However, whatever you do, do not penalize failures. Remember the Hawthorne effect. You don't want your teams to become afraid of checking in changes. Right? The final metric we'll be looking at is MTTR, or mean time to recover. Again, GoCD's analytics plugin shows you the mean time to recover easily enough at different parts of the value stream. It captures the time between a previous failure and the next success and averages it across failures across time. So in this case, it's 1 day, 3 hours to fix the failures. Manually or in another tool, you need to capture the time of failure and success and use that to calculate the mean time to recovery. In this example, there was a failure on day 1 at 10:15 a.m., which was fixed at 1:25 p.m. with a recovery time of 190 minutes. Then there was a failure on day 2, which was fixed later for a recovery of 404 minutes. Taking the mean of those gives you the mean time to recovery. Okay. Slow cycle time also shows up as high MTTR sometimes. If it takes a long time for a fix or a revert to go through the pipeline, then the MTTR might be high. Other reasons could be that no one cares or failures that are hard to pin down. Effective mechanisms we've seen to combat high MTTR include an unquestioning revert of failing commits or stopping the line. That's an effective strategy from the lean world where anyone can cause the assembly line to stop so that problems don't propagate further down the pipeline. New changes can only go in once failures are fixed and root causes identified. All of these metrics feed off of each other to help you understand what's happening. I know we went through a lot of information really quickly. We'll be sharing the slide deck soon, and we have time for questions coming up where we can go through this in a little bit more detail if needed. Just a reminder, you can use the Q&A button at the bottom of Zoom to ask questions. However, what you need to remember is that the context of the team or the organization is really important to understand everything that's happening. You need to decide on the right set of metrics to ensure that you improve your delivery process without adversely affecting the behavior and the culture of the people on the team. Suzie?
Thanks, Aravind. Like we just said, we've covered a lot in a short space of time. So before we finally finish, I just want to review some of what we've covered and reiterate the important takeaways for you all. So the first off is metrics are important to help you set goals, improve your continuous delivery process, and predict your future behavior. Be thoughtful about what you measure. We've suggested you start with throughput, cycle time, failure rate, and mean time to recover if you don't have any other specific needs. Once you start looking at your data, look for connections between those metrics. As you saw in our examples, a low throughput may actually be related to a slow cycle time or a high failure rate. So pay attention to multiple metrics and understand more deeply what's happening in your process. Of course, you need to understand your context to understand how to improve as well. So do your teams work in branches, and could this be limiting throughput? Have you added lots of new staff that could be increasing cycle time, but it might be temporary? These kind of details will help you make sense of your data and help you to improve those metrics. Remember that the whole process is really about feedback. So you need to make sure that you review and change and improve your process based on what you learn from your metrics. And finally, you should consider using tools like GoCD to help you capture and visualize your data. They will allow you to share your data and give everybody access to the same information and really help you to pinpoint opportunities to improve your process and to change. We've got some additional resources here for you. So when you get the copy of your the slideshow that Aravind mentioned, you'll be able to review these additional resources and learn more about how to use metrics for continuous delivery. And now we have time for questions. As we mentioned before, please use the Q&A button to ask us a question. And also, while we're running the Q&A, you'll start to see a poll of 3 simple questions. And that poll actually provides us with feedback about this webinar. It's going to help us to improve the webinar. So we really value your feedback. Please take a second or so to complete the poll. And now we're going to take a look at those questions. So we have our first question actually, and it's about GoCD. The question is GoCD open source? And what is the difference between the open source and the commercial products? I think that sounds like one for Alagu, so I'm going to let Alagu take that question.
Thanks, Suzie. So GoCD is completely open source and free to use. So, and there is a commercial support and enterprise add-ons that you can subscribe to, and you would get all our enterprise add-ons such as the Analytics plugin, the LDAP authorization, and a couple of others which come along bundled with support from the core development team. And so but the whole product is completely open source and free to use.
Great, thank you, Alagu. And we actually don't have many questions right now. So if there are those of you still sticking around who have questions about the content, please ask them, because that's what we're here for the next few minutes. And okay, we have one. I'm going to ask Aravind to actually take this question.
Sure. So the question is, does GoCD support pipeline as code? The answer is yes, of course, it does. GoCD supports pipelines as code with JSON and YAML. In fact, it is a it as an extensible endpoint. So you can even write your own kind of pipelines as code. For example, there is a Groovy plugin for pipelines as code, so you can programmatically define your pipelines. Apart from just pipelines as code and checking that in, there are people who use tools such as Gomatic, which ends up defining the whole pipeline, or not the whole pipeline, the whole config of GoCD in Python. And there are other such things in Ruby, etc. So yeah, definitely. We really are big proponents of versioning everything. You even saw it in the continuous delivery definition mentioned earlier. So yeah, we've always been interested in supporting those kind of workflows. The other question, another question that is here is, any suggestions or best practices to consider while doing VSM exercise with teams? Suzie, do you want to take that while I think about it?
Sure,
I'm guessing it is to your earlier point of drawing a VSM.
Yes, I can provide some suggestions. Having done this with teams of my own, one thing that is actually very interesting to do, and my suggestion would be, is that you don't just involve your technical team. So I think often people think that value stream, continuous delivery, continuous deployment, this is all about technical practices, and they just talk to their development teams. Potentially they talk to their operations teams. If they've moved to DevOps teams, they would include those people. But one thing that I would definitely recommend is that you actually include people from the business side of your organization. So should those be product managers or subject matter experts, stakeholders that you have, anybody who may be in your customer service, all of those parts, all of those people will understand parts of the process that your technical teams don't. And that's actually very insightful to understand where they think the beginning of the process is, and where they think actually where the value gets delivered to your customers. And it can actually be a lot more than your technical teams have insight to. So that's one suggestion, is in order to understand the full value stream, it's to include people from across your business to do that. And the other thing is to make it very visual. That's my second recommendation. As much as possible, I would recommend that you first do this on a large whiteboard or on a large open area, so that many people can come along and take a look at it. And I've actually often seen people walk past and realize that there's something missing in a process, or have a suggestion where actually something is very different. So that's a second recommendation, is make it visual. And then just as I was saying that, I actually remembered a third one that I would do is make sure that it's the truth. So when you begin doing your value stream, don't start with doing your to-be, what you would like it to be, your ideal, your theoretical value stream. Really try to do the one that is actually the truth. It actually allows you to see quickly where you can improve that process if you're very truthful about it. So those are my three recommendations. Include a wide range of people in your organization, make it visual, and then be truthful. I'm not sure, Aravind, if you have anything to add to that.
Just one small point to add. I think that it doesn't need to be you don't need to start with a big bang. You can start small. Just start with what you know, what your team knows, and then you can take that to other people and get them to expand it. So don't think of it as, oh no, it's a big value streaming process. Even that small one that I've done when I've joined newer projects on clients has helped them understand some things that they didn't know about just by talking to people. So don't think of it as a huge exercise to start off with. Another question is there any live demo available that we can see or show to our clients so as to better explain the benefits of it to them? Yes, GoCD is an on-premises software, so there is no hosted solution for it. However, we do have a Docker Compose-based demo, demo setup that we can share with you soon. Suzie is actually working on improving it now. That allows you to see pipelines and value streams within, a minute or however long those Docker images take to start up. So this is asked anonymously. So if you would like to write to us at, let's say, support@thoughtworks.com, or to Suzie and me at suzie@thoughtworks.com, or arvind@thoughtworks.com, please feel free to do that, and then we can take care of that, or we can help you in other ways if you need.
Yeah, we would be happy to share that with you. As Aravind said, we're working on it. It takes a few minutes to bring it up right now. So yeah, get in touch and we'll be happy to share that with you.
Do you want to take another one, or should I take one?
I am just reading them. Let me see.
All right. So let me then take another one.
Okay.
So it's like, the question is, how does it work when we have CD with different and many short services? I need to understand about failures. It's not entirely clear what the question is to me, but I can give you a question. I can give you an answer related to microservices, which kind of fits in this case, maybe. If you need to clarify, please do that, the person who asked the question. So in a microservices setup, what ends up happening is that you have multiple services which need to come together eventually, but they're all independent by themselves, right? They all have their own tests. They could all be written in their own languages. They all have their own databases. They are independent services overall. So what you would do is that you need to think about setting up pipelines in your value stream for those individual services to run their own tests. But finally, you need some kind of an integration point to bring together the services to make sure that, things like not contract tests, things like integration tests across services work. If you're very disciplined about it, contract tests written at the service level will give you that confidence. But oftentimes what I've seen is that versioning becomes a problem. Like a newer version of a service, will it work with an older version of the service? You need to be very, very careful about how you define your contracts and APIs and all that. And a CD pipeline can help you define that well. In GoCD's case, it has this feature called fan in and fan out. So you could have these individual services with their own pipelines, and then all those pipelines could fan in into an integration set of pipelines, and you can deploy them separately. But you would have them every time a service changes. You could have the whole suite of tests run across services if that is what you want. The last part of that was, I need to understand about failures. I don't know exactly what the question is, but my understanding is that it is not very different from seeing failures of a single part of a pipeline. If service A has a lot of failures compared to service B, maybe you need to spend more time on that and figure out the quality of that, figure out why that is happening, and so on.
I actually have something to add to this question as well. To me, it sounds like a question about microservices, and that's how you answered it, Aravind. I would suggest if you take a look at our blog at gocd.org, our latest blog post there is about remediation strategies for continuous delivery of microservices, and it talks a little bit about how you might do some of these understanding failures, what you might do when you have a failure in a microservices situation. Depending on your question, that might be relevant. So that's something that you might want to take a look at there. And I think the final question that we have right now, but the question and answer section is still open, so please please post your questions there, is around Jenkins and GoCD. So the question is using Jenkins for continuous integration and GoCD for continuous delivery the best approach to complete your pipeline? I'm going to take a stab at that, Aravind, and help me out if I falter. So that is definitely something that we see. So I want to say that at the very beginning, we do see that teams will use Jenkins for continuous integration and can go for continuous delivery. However, you asked for the best approach, and we actually believe that GoCD is able to model and provide you all the functionality that you need from the very beginning of the process, from the code commit to production deploy. So GoCD has continuous integration features. There is no need to use another tool like Jenkins or any other continuous integration tool. Using GoCD for the whole value stream, for the whole pipeline, would be the best approach, in my opinion. You can take a look at the different types of materials that we allow for input. And of course, if Jenkins is something that's stuck there in your process and is not an option, you can, of course, pass materials in from Jenkins through to GoCD. But in terms of the best approach, we would recommend just using the one tool. Do you have anything further to add to that?
No, I agree with you. The last part that you mentioned about Jenkins already existing in an organization, I believe happens often. So, it's like a sunk cost fallacy, right? You put in a lot of work and investment into it, and, you don't want to get rid of it. That's understandable. If possible, our recommendation would be to see whether using one tool works for you. So in GoCD's case, if you use it, then it gives you total end-to-end visualization of, using the VSM, which you will lose if you use a different tool for that. And another one is, I think Suzie alluded to this, if you really want to use it in that model, it is possible. GoCD has a good support for APIs. So if you look at api.gocd.org, you will see quite an extensive and improving API support. So you could use that to create, you could use that to create it the way that you want, using two tools if it works for you. Another question here is, what data is being collected by GoCD automatically? Is KPI-based analytics embedded into GoCD by default? If so, can we extend it by defining custom metrics on top of the collected data? The GoCD analytics plugin that we showed there is a paid or commercial add-on to GoCD. There is a trial available if you're interested to see if it is useful to you. So again, please feel free to reach out to us at support@thoughtworks.com, or if you go to gocd.org/analytics, you should be able to sign up there to get a trial of that. However, the analytics plugin, GoCD, as Alagu mentioned, is open source, right? So the analytics plugin is built using all the open source components of it. So there is a notification endpoint which people use with Slack notifications and other things. We have used that to ingest data, which the notification endpoint is putting out. And then we've put in a lot of effort into figuring out the right metrics, figuring out how to show it, where to show it, all of that. So yeah, it's paid. It's built on the open extensions and components, nothing special that we have any kind of access to. Yeah. So about extending it, at this point, you can't extend it with custom metrics. But that's something we can look at. If you're interested, please talk to us. Talk to us about what kind of metrics would be interesting to you, and then maybe that will help us too.
Yeah, there's one thing that I would add is we're actually offering a trial of that analytics plugin right now. So if anybody is interested to try it out and see what is available there, we're very interested in feedback about the visualizations and the type of metrics that we actually provide by default, feedback around what could be added or improved. So you can go to gocd.org and take a look at the trial and help us to improve that experience and talk about how we might be able to extend it. It looks like that is all of our questions. Aravind, Alagu, I don't see any others.
Yeah, that's right. I mean, if you have other questions at any point, you can always talk to us, each one of us individually or at support@thoughtworks.com. And we will probably follow up with an email with some of this information and the slide deck and so on. So it'll probably have our email addresses there as well.
Okay. Well, thanks everyone for sticking around, asking questions, and get in touch if you want to know more.
Yep. Thank you very much,
Thank
everyone.
you.
Thank you.
Thanks. Bye.